For question number 6, explain how glycogen synthesis and glycogenolysis regulate one another, and how does insulin regulate glycogen synthesis and glycogenolysis? So first of all, glycogen synthesis is when we want to make and store glycogen because we had just eaten a meal and now our blood glucose levels are high, so we want to take that excess glucose and store it as glycogen through glycogen synthesis. We also have glycogenolysis, which is when we want to break down glycogen and convert it to glucose because we're exercising and we need that extra ATP and energy to the muscles. And so how these two regulate one each other is when one is enhanced, that inhibits the other, and when the other one is enhanced, that inhibits the other, because you never want them both turned on at the same time. You never want to be storing and breaking down glycogen at the same time, because either you're wanting to store it or you're wanting to use it for glucose and to supply the muscles with energy. And so these two are regulated. Glycogenolysis is regulated by hormones such as epinephrine, norepinephrine, glucagon, growth hormone, calcium, and the concentration of phosphate, ADP, and AMP, while glycogen synthesis is regulated by insulin, which is the opposite hormone to these. When these hormones are released, we're wanting to exercise. When insulin's released, we're wanting to store glycogen or store glucose as glycogen. And so how glycogenolysis works is when these hormones are released, that activates adenylate cyclase, which activates converting ATP to CAMP. When CAMP is created, that activates protein kinase A, which activates glycogen phosphorylase kinase, which activates glycogen phosphorylase, which then triggers glycogen to be converted to G1P and to start glycogenolysis. And so in addition to that, we also have when calcium's released, that activates glycogen phosphorylase kinase even more, and with calcium, that activates CAMKK, which activates glycogen phosphorylase and glycogenolysis even more, as well as this concentration of phosphate, ADP, and AMP also activates glycogen phosphorylase. So this glycogen phosphorylase is receiving 4 times the signal to increase glycogenolysis, which is good because when these hormones are released, again, we're exercising and we want this glycogen to be broken down and eventually converted to glucose to help with glycolysis in the muscles. Now, when we have an excess amount of glucose in the blood and we want it to be stored as glycogen, we want glycogen synthesis. And so when that happens, insulin is released and that activates protein phosphatase 1 or PP1. PP1 itself goes and inhibits adenylate cyclase, and that essentially stops this process from hopefully continuing glycogenolysis or inhibiting it as much as it can. But in addition with PP1, that also helps inhibit glycogen phosphorylase kinase, which we see down here receiving 2 times the signal because we have the initial hormones as well as calcium. It helps inhibit glycogen phosphorylase, which is important because that is now receiving, like I said, 4 times the signal that tell glycogenolysis to happen. So we don't want that to happen. And this is also important because these hormones may not be released, but if we're exercising, these are happening. So this is continuing to send signals to this process of glycogenolysis regulation that it needs to, keep going. So it's important to shut off these enzymes as well, not only this one up here, but also these, because these are sending signals to tell that to go. And it also has glycogen synthase, which is what the enzyme used to create glycogen, and that inhibits protein kinase A. And essentially when glycogen synthase is activated, that will inhibit protein kinase A, which will inhibit glycogenolysis. So that's one way that they regulate each other, as well as when protein phosphatase 1 is activated, that inhibits adenylate cyclase, so that inhibits glycogenolysis. So that's another way they inhibit each other. And overall, when there are these hormones present, this process is most likely to occur. When this hormone of insulin is released, that's going to inhibit these processes from happening. And so how they regulate one another is when one is happening, the other one shouldn't be, and vice versa. And how that happens is through this release of hormones. And when these hormones are released, they activate certain enzymes that inhibit one another so that one process can continue on like it should and the other one is inhibited. Because again, you don't want to be storing and making glycogen. You don't want to be storing and breaking down glycogen at the same time, because you either want to be breaking it down to help fuel the body for exercise, or you want to be storing it because you have excess amount of glucose in the bloodstream.